Let us start this. Bismillah. Analysis of first order measurement system in time domain. Okay, this is the next subtopic. Before going into this thing, I would like to cover different citations used in analysis. Right? Are you ready for that?
Yes, sir.
Yeah. Let us suppose that this is our measurement system. We want to get it analyzed. So, in order to do the analysis operation, we need to apply some input and measure the output. Okay. Applying input is called as excitation. क्या बोलेंगे इसको? Excitation.
Excitation.
And measuring output,
Response.
okay, to the excitation is termed as response. Let us first cover what are the different excitation we may have in this domain. What domain? Just read this.
Time domain.
Time domain. Okay. The first one is called as step excitation. Or unit step signal. It is represented by U letter, U of t is equal to 1, or sometimes we can call as k into 1. Okay. For simplicity, assume it to be 1. For time t is equal to 0. And it is equal to 0 in else cases. Hope it is clear to everybody.
Yes, sir.
Yeah. If we make the drawing of this, it looks something like this. Suppose x-axis t, y-axis is magnitude. Suppose magnitude 1 is available somewhere here. So this y of t is equal to 1 from 0 to infinity. And it is equal to 0 in else cases. Is it clear?
Yes, sir.
Yeah. If suppose I apply Laplace transform on this equation, Laplace transform of u of t, yeah, tell equal to how much? Laplace transform of unit step signal is equal to how much? जल्दी से बोलो. भूल गए? Forget it. It is equal to 1 by s. Correct? Agree or not?
Yes, sir.
Only one person is agree or everybody? Okay. The second excitation we use is called as ramp excitation. Okay, ramp excitation. The ramp excitation is represented by letter R of t, and it is equal to time itself. Sometime kt. For simplicity, I am writing t, where k is constant gain. For time t, This is greater than or equal to 0. And this is also greater than or equal to 0. And 0 in else cases. If you try to make the sketch of this, x-axis t, y-axis r of t, you will be getting a linear line, straight line. Okay, so this r of t is nothing but equal to just t. So relation between r of t and t is simply a straight line. Is it clear to everybody?
Yes.
Yes, sir.
Yeah. If we apply Laplace transform on this type of equation, so what answer we can get? This is also well known thing. Laplace transform of t. It
1
is
by
equal
s.
to 1 by s square. Laplace transform of t is equal to 1 by s square. Is it clear? Should I proceed?
Yes, sir.
Yes, sir.
Yeah. The third one is
Impulse excitation.
Impulse.
impulse. Impulse excitation. It is represented by letter delta of t, and its value is equal to 1 or k times of 1 at only one instant of time, that is t is equal to 0 or it is equal to 0 else cases. Okay, observe this here. Only one instant of time, and this is infinite instant of time from 0. This is also infinite instant of time from 0. Observe this. This is infinite instant of time starting from 0. How about this? Infinite instant of time starting from 0. How about this?
At t equals to 0.
Only one instant of time. It is how much? One at only
1
one.
at t equals to 0.
ये जहन में रखना बेहद जरूरी है, right? That is very very necessary and important information to be there in our mind, right? So impulse excitation exists for only one instant of time. इसको क्या बोलो आप? Infinite बोल दो. इसको क्या बोल दो? Infinite बोल दो. इसको क्या बोलेंगे? How about this? अरे बोलो
1
बाबा.
instant of time.
Right.
Exists only one instance of time.
One instant of time. ठीक है, ये important बात है. Okay. Let us see the Laplace transform representation of delta of t. So, how much it is equal to? How much? No idea. कुछ भी याद नहीं है हम लोग सब भूल गए. So it is equal to again 1. But for all values of s, ये important है. For all values of s. Is it clear? You observe
Yes,
this.
sir.
In time domain, impulse exists for only one instant of time, whereas in S domain, that is in Laplace domain, it exists for all instants of S. Hope it is clear to everybody.
Yes, sir.
Yeah, if I make the sketch of impulse, suppose this is represented by delta S. Yeah, it is equal to 1 Delta S is equal to 1 for all the values of S. Whereas in time domain, delta T is equal to 1 at only instant of time 0. Please observe this. At only this instant, delta T is equal to 1. In S domain, the case is like this. In time domain, the case is like this. Is it clear to everybody?
Yes, sir.
This is time domain and this is S domain. कोई एक बच्चा भी नहीं पूछ रहा सर यू सेड टाइम डोमेन एंड फ्रीक्वेंसी डोमेन फ्रॉम वेयर द एस इज अपीयरिंग ये क्वेश्चन नहीं आ रहा आप लोगों के जहन में should I cover that or should I skip this assuming that you know this should I assume that you know this
Yes, sir.
what yes no or don't know
Voice.
We got S domain is frequency domain.
as domain is nothing but frequency domain only, but this is actually a complex variable. S is equal to sigma plus j omega. Okay, this is S domain. If you want to
Yes.
extract only frequency domain from S domain, from these, क्या करना पड़ेगा हमको? We need to assume sigma is equal to 0. ये एक हिस्सा है जो आपको याद रखना पड़ेगा. The only difference between S domain and frequency domain is, in case of frequency domain, the sigma term of complex variable S is 0. Is it clear? Yes, no. So here
Yes,
S
sir.
is j omega. To get frequency domain from S domain, we need to write S is equal to j omega. This I already told you. So hope it is clear. The first topic of today's class, that is nothing but different excitation used in analysis under a time domain. First one is step excitation, second one ramp excitation, third one impulse excitation. So step excitation is given by unit step excitation in particular is given by this relation u of t is equal to 1 for t starting from 0 up to infinity. So this is represented as t greater than or equal to 0 and it is equal to 0 in else cases. So its drawing is like this. From 0 to infinity, its magnitude is 1. So if you try to see or observe the Laplace transform of this, because this is needed, that's why I am giving this relation, we will get Laplace transform of u of t is equal to 1 by s. Okay, is ramp is equal to r of t is equal to t itself. Okay, we are considering unit ramp. If it is k magnitude ramp, we can write k into t, right? K into t. So in this case, I'm assuming it to be unit ramp. So that is equal to t from 0 to infinity. So it is represented as t for t greater than or equal to 0. And it is equal to 0 in else case. The sketch or drawing for this is represented like this. From 0 to infinity, r of t is just equal to t. So the relation between r of t and t is a straight line. Its Laplace transform is 1 by s square. Impulse excitation magnitude is 1 for only one instant of time. That is for t is equal to 0. So Laplace transform of this impulse function is again 1, but the difference is for all the values of x. So if we try to make the sketch of this in S domain, it look like this. For all the values of x, for all negative and positive values of s, so the Laplace transform of impulse function is looking to be 1. Whereas if you see the plot in time domain, it is equal to 1 for only one instant of time. Impulse कैसा है मालूम है? एक pinch दिया वैसा है. Just apply a pinch and leave. Just give a trigger and release. Okay? उसका response देखो in S domain. So it is covering all the values of S. That is the significance of impulse excitation. Hope it is clear to everybody.
Yes, sir.
Yes, sir.
Okay, now I am starting a long answer question. Be ready, be attentive. Please show the presence of your mind in the class. Then only it become convenient for me to cover smoothly. Okay, now on your screen, I am presenting now analysis of first order system for step excitation. This is called as step response of first order measurement system. This is expected long answer question. Okay, are you ready for that? Ready with your notebooks?
Yes, sir.
Okay. So first write down the first order differential equation. Please see your notebook and help me. A1 d by dt of x0 plus a0 xo is equal to v0 into,
VO into X1, XI.
okay. Apply Laplace transform on this equation. You will get a1 s plus a naught whole times x0. Can I write like this? The Laplace transform of d by dt is s, assuming 0 initial condition, and the Laplace transform of xo is xos. The Laplace transform of xo is xos. Xo is xos. In both the cases, xos is appearing. I'm taking common. I'm writing a1 d by dt is nothing but s. Okay, a naught as it is. A naught. Is it equal? Sorry, is it clear?
Yes, sir.
Is it, yeah, that is equal to xi of s into b naught as it is. So try to write output by input expression. So we can write this as b naught divided by a1s plus a naught. So try to separate the, okay, try to make this constant term in the denominator 1. So this is possible if I divide numerator and denominator by a naught. Can I write like this? Yes, no.
Yes, sir.
Yeah. So this term I'm okay, no problem. Let it be xo s by xi s. So I'm assuming this term to be k and a1 by a naught to be tau. Okay, please note down this. Please write with me. Okay, accordingly, I am rewriting this equation. XOS divided by XIS is equal to K divided by tau S plus 1. Everybody write up to this thing. Call this to be equation number 2. Earlier we used equation number 1, so call this to be equation number 2. This is over, let me know. Fasahat
Completed,
is
sir.
there. Fasahat is there in the class. Fasahat,
No,
are
sir.
you there? He is not attending classes.
He is attending, sir, daily.
Okay, today he is not there.
Yes, sir.
Okay, so everybody finish up to this thing. Yes, no.
Yes, sir. Completed.
Okay,
Yes, sir.
okay. Call this term K to be given and tau to be time constant. Time constant. You see the coefficient of S in the denominator is called as time constant. And the constant appearing in the numerator is called as gain. Sometimes this equation will be given and ask you to find out step response of first order system for this type of equation. So by looking at this, we can say that this is belonging to first order category. Okay, because you see the denominator, this term, the denominator equation is called as actually characteristic equation. क्या बोलेंगे इसको? What is this called?
Characteristic equation.
This is called as characteristic equation. What is the highest order of this characteristic equation? Observe the order.
And
It is equal to 1. Therefore, this is first order system, right? You see the order of S term.
Yes,
Order of
sir.
S term. It is equal to 1. So, this is first order system. अगर ये equation दे दिया and ask you to find out, okay, step response of this equation. So, sorry, this system, ये equation is system. That in that case, we assume that this is nothing but first order system and we need to proceed for first order system. So, can I proceed further?
yes,
Now consider the case of, consider xi of s is equal to 1 by s because it is given in the question. What is asked to find out? Step response. ये term समझना बेहद जरूरी है. Step response means response to step input. Step response का मतलब क्या है? What do you mean by step response? Response to. बोलो बाबा. देखो इंटरैक्टिव रही तो ही होती है.
Response to step input.
हाँ, वरना बोर हो जाते आप लोग, सब्जेक्ट में इंटरेस्ट नहीं आता. Step response means response to step input. So what is input in this relation of XOS and XIS? This
Excite.
is excitation. So given excitation as a step, so I can consider xi of s is equal to 1 by s. Just now I told you Laplace transform of step input is nothing but 1 by s. In bracket you can write as given. Right? Is it okay or not? Can I proceed?
Yes, sir.
Yes, sir.
So therefore I can write xo of s is equal to xi of s. I'm writing cross multiplication. So that will be 1 by s k divided by tau s plus 1. Is it okay? Is it okay or not? This step?
Yes, sir.
Okay, I'm writing 1 by s as I'm actually trying to separate the s term from this equation. So for that, what I am doing is I am dividing by tau. Can I write the equation like this? 1 by s
Yes, sir.
k divided by tau into s plus 1 by tau. Is it okay? Can I proceed?
Yes, sir.
The reason for doing this thing is because we need to take inverse Laplace transform. So inverse Laplace transform is convenient, readily available formulas are available for this type of equation, not for this type of equation. That's why I'm taking or separating a tau term from this s. So for that I'm taking tau outside. So if tau goes outside, this s will be separated with tau, and one will be having the effect of tau in the denominator. So 1 by tau is required. Okay. Now we have x of s is equal to this relation. Hope it is clear to everybody. Yes, no.
Yes,
Yes,
sir.
sir.
Okay, what is the next requirement? यहाँ देखो आप क्या पूछा है क्वेश्चन में? We need to get response of first order system. Response of first order system is nothing but response in time domain, not in s domain. Okay, so our target is to get, what is our target? Is to get what? XO of t. Is it clear to everybody?
Yes, sir.
Yes, sir.
This is our target, to get XO of t. How to get XO of t from XO of s? यहाँ देखो, ये है हमारा XO of s. यहाँ चाहिए हमको XO of t. कैसे लाएंगे भाई? How can we transform this XO of s into XO of t? जल्दी से बोलो. This is possible if I apply inverse Laplace transform. ठीक है? This is possible if I apply, बोलिए.
Inverse Laplace transform.
We need to apply inverse Laplace transform on this equation to get XO of t. Let us see how. Let us see to. Okay, let us proceed towards getting inverse Laplace transform of XO of s. So to do this thing, resolving XO of s into partial fraction, right? If we do this, then only we will be able to find out inverse Laplace answer. So we need to resolve this equation into partial fraction. I think you are aware of this practice. Yes, no. Yes, no. Please. Are you aware of this practice? One s
Yes, sir.
yeah. S domain equation is given and ask you to find out time domain equation. For that, we start with resolving into partial fraction, then using the available direct relations, we can get the inverse Laplace transform answer. I think hope you are aware of this thing, this practice. So I'm proceeding. I'm taking next screen for that. So only 5 minutes left. So I will split this into only two parts. Okay. So we have the equation xo of s is equal to 1 by s. So I can write k by tau s plus 1 by tau. Okay, this we need to resolve into partial fraction. So I'm resolving like this. A by s, okay, plus b by s plus 1 by tau. Is this a partial fraction? Is it resolving clear to everybody?
Yes, sir.
Okay. Now we need to find out this a and b value. So to find a and b value, how can we write the equation for a? A is equal to xo of s into s for s is equal to 0. Similarly, b is equal to xo of s into s plus 1 by tau for s is equal to minus 1 by tau. Is it clear to everybody? Yes, no?
Yes.
Okay. What is xo of s? Xo of s is 1 by s k by tau s plus 1 by tau. So if I write into s, so this s get cancelled and substitute s is equal to 0, we will get as. बोलिए क्या आ जाएगा? A is equal to A will become how much if you substitute s is equal to 0? Tell me the answer. Substitute s is equal to 0.
K.
Okay.
Is it okay? Is it okay to everybody?
Yes,
Give me
sir.
a- Similarly, solve this equation and tell me the answer. What is the answer?
Minus K.
Great. Everybody getting minus k? Few more confirmation. Few more confirmation, please.
Yes, sir. Minus Q.
Okay, great. So b is equal to minus k. A is equal to plus k. B is equal to minus k. Substituting a is equal to k, b is equal to minus k in this equation. So I can rewrite this xo of s is equal to k into 1 by s minus 1 divided by s plus 1 by tau. Is it okay? Is it clear to everybody?
Yes, sir.
Okay, now we need to find out inverse Laplace transform of this equation. Can I move to next screen?
Yes, sir.
So we have xo of s is equal to k times 1 by s minus 1 by s plus 1 by tau. We need to get inverse Laplace transform of this part and this part because Laplace transform support the linear equation. Sorry, the principle of linearity. Separately, we can find out inverse Laplace transform of this part and inverse Laplace transform of this part. Right? Separately, we can find out and substitute. So, what is inverse Laplace transform of 1 by s? जल्दी से बोलिए.
1.
Great. Inverse Laplace transform of 1 by s plus 1 by tau. It is like 1 by s plus a. Shift property of Laplace transform. So this can be e to the power minus a. A is what? 1 by tau times t. So this I can write e to the power minus t divided by tau. Is it clear to everybody? कैसा है मालूम है? ये 1 by s plus a के वैसा है. Okay? 1 by s plus a को कैसे लिखते हैं अपन? e to the power minus class level. E to the power minus at. A की वैल्यू क्या है? 1 by tau. Right? That's why I am writing like this. ठीक है? Is it clear to everybody?
Yes, sir.
Therefore,
Yes, sir.
therefore, I can write in place of this. I can write xo of t. Correct? K because it is constant. I can write k. Okay. 1 by s is nothing but t. 1 by s plus. Sorry, it is not t. It is 1. It is 1 minus 1 by s plus 1 plus 1 by s plus 1 by tau is nothing but e to the power minus t divided by tau. Is it clear to everybody?
Yes, sir.
This is nothing but the step response. Step response of first order system. Which system? Measurement system. This much is enough for today's class, right? Any doubt up to now?
No, sir.
Okay, now give your attendance. Please request your friend to be regular in the classes. Important topic is under discussion. Okay, give me your attendance. Answer your attendance. Roll number 1,
1 present, sir.
2,
2 present, sir.
3, 4,
3 present, sir.
5, 6, 7, 8, 9, 10.
10 present, sir.
This second we are recording.